So today we will be understanding nested loop, right? What is a nested loop? Nested loop is a loop inside a loop, right? So this is our list, right? For example, this is our list A equals to 1, comma 2 and 3, comma 4. These are two lists inside a list, right? So this is list inside a list, right? Then how can we access it, right? But in actual memory, how it is stored, right? Let's us understand that. So we can understand using metrics, right? We can say that it is stored like this, right? 1, 2, 3 and 4, right? These are the rows, right? These are the rows and these are the columns, right? These are the columns, right? These are the columns. Now this is stored like this, right? 1, 2, 3, 4, and this is one list and this is another list, right? And then we can say this row represents what? This row represents zeroth row, first row. This is zeroth column, first column. But in one value, how one value we can extract one value using their index number. Now, what will be the index number of this row? We have to this element. We have to understand that its index number is zeroth row and zeroth column, right? Its index number is zeroth row, first column, right? Its index number is first column for first row, zeroth column, right? And its index number is first row and first column, right? So this is how it is stored, right, inside the memory, and we can access each element using their index number, right? And this is the index number, right, of that element, right? So now to access these elements, what can we do? We can say for, right? For loop we can run for I in range of what? Len of, right? Range will give us the range of the length which will be there, right? Range of len of from where? Len of a, right? Len of a. We can start our range from 0, right? And we can end till len of a, right? Now here I, this zeroth index, in zeroth index, I will go to zeroth index, right? I will go to the zeroth index, right? I has reached where? I has reached here, zeroth row, right? This will give us length of row, right? This will give us length of row, len of a. What it means? Length of row means how many elements are there, right? So there are 1, 2. So there are 2 elements. So it will give us length of row, right? Then we can loop inside this loop. We can say for to go to column, right? For j in range of len of what? A of I, right? A of I. Why A of I? Because we want to go to the column of each row, right? Each rows. So we don't want to go to more column. We want to go to each rows column, right? So it was inside this zeroth row. So we want to go here. We want to go here. Then we want to move to the next row, right? Then we can go out of J loop, right? Here I have decided for j in range, right? This for second loop means for this loop we want to go out after second column, right? So we want to say length of the row, right? The length of that row, right? Rows column, right? So it will give us length of that rows column, right? Then we can say what we want to do. We want to print. So once we have reached our first element to our first element, what do we want to do? We want to print it, right? We want to say a of I and j, right? We can say that I want to print it, right? Then I can say comma and it with equals to, and it with this white space, right? And it with this, I can say this, right? So what I want to say? I want to say first go here and print it, right? Then give some gap here, loop through this another column, right? And print this. Means one white space will get printed between these two elements, right? And then we can say you can move out of the loop, and once you move out of the loop, before moving out of the loop, you can say print next line, right? Next line will get printed, right? So this is how we can print it in the form of a matrix, right? In the form of a matrix indentation, right? So control X, yes, enter Python 3, what nested.py, set.py. We have made an error, right? We haven't put this here. Select, yes, enter Python 3, nested.py, right? Now let's understand what is a function. Function is a block of code which will run only when we will call it, right? So it can be done any number of times and it can be called any number of times, right? That is a function, right? Function is a block of code which will run anytime it will be called, right? So for example, how can we define a function? We can define a function using def keyword, right? Def and function name add, right? For example, we give our function name as add, then we can put colon here, right? And then what we can do? We can say print anything. Let's say for example, I just want to print value, some value, right? And then I can say call this function, right? Add, call this function, and I can say control F, yes, enter, and then I can say Python 3 nested.py hello has been printed, right? So this was about simple function, right? Then in this function only, in this function only, this function nano nested.py, right? This function only can contain a return type, right? But this time it doesn't contain any return type, right? It hasn't given anything, any return value, right, to this function, to wherever we have called. Now we can give it a return type. We can say, for example, we have a function add, right? Then we can say x equals to x contain 100, right? And y, we have another variable which contains y equals to 100, right? Again 100, right? We can say return. What to do? Add these two, right? We can say return x plus y, right? Return x plus y, and then we can call this function, right? We can call this function in z, and we want to store the value in z, and then we want to print it, right? Print z, right? Print z, right? Control X, yes, enter Python 3 instead.py, right? 200 has been printed. This function has been added, right? What is happening? We are calling the function, right? X is assigning 100 to it, y is 100 assigned to y, and then it will return x plus y. It will add it and return it to z, right? This is happening. Now, it doesn't contain any arguments, right? Now it can contain arguments and parameters, right? What are parameters? Parameters are defined in a function definition, right? Whereas arguments are defined during function calling, right? So let's say, for example, I want to return x plus y, and I want to put x here, y here, right? I want from the function caller that give me the value of x and the value of y. This x and y that we have added here is the function parameter, right? And then we can give x and value of x and y here. We can say, for example, 10 comma 20 I want to give, right? So this 10 and 20 is an argument, right? Which is given to the function, right? Then we can say control X, yes, enter, it will be added, right? It got added, right? So this is about argument and parameter, right? So we can have we should have same number of uh, argument as our parameters. But for example, we don't know how many arguments are there, right? We don't know how many arguments will the function caller be giving, right? We can say asterisk x, right? For example, asterisk x, and let's say we have defined y here, y equals to 20, right? So now this function caller may give one argument, or may give 3 to 4 arguments, right? For example, 56 comma 80, right? 4 argument has been given. Then how to decide which argument to accept, right? So our parameter only contains one variable, but asterisk will say that, okay, our function caller will give any number of arguments, I will accept it. But how to decide which argument to accept, right? I have to decide it using this x equals to x of what I want to. I want inside X, right? For example, it has given four argument to us, right? Which argument we want? If we want zeroth index argument, we want first index argument, we want second index argument, we want third index argument. For example, I want third index argument, right? Right? Let's say x of 3. I want x of 3 and then return x plus y. Now it will print it right? Control X, yes. Python C nested.py, right? Hence it has been given. So this is how we can say that we don't know number of arguments, but we can give asterisks to it, and we can decide which number argument we want to take, right? Which index number argument we want to take, right? So this is called this is if we don't know number of arguments, right? For example, we can also pass what we can also pass key value pair right here. For example, if we have something, right, if we have something age, right, and we want to add age, right, we can say age equals to 10, or we can say class, right, we want to add class equals to 12, right, for example, and now it will accept the value of what, class and age, right? We can say age, comma, class, right? It has accepted age and class value, right? And we have given age and class value to it, right? And also class we don't have to define because it is already a keyword. We can say in place of class we can say what, salary, right? We can say salary. We want to age. We want to add salary and age, right? Let's say for example, right? So we can say salary equals to this, and age equals to this, right? And we will accept age and salary here, and now this x, not x, we will directly add these two, right? We will uh, directly add these two. We can say I want to add age plus return age plus salary, right? Age plus salary. Now 10 will be stored here, 12 will be stored here, and it will print 10 plus 12, 22, right? Control X, yes, enter. Right, so 22 has been given. Let's say for example, we have what? We have key value pair here, right? And we don't know how many key value pair will be there, right? How can we say we can define parameters? We can say asterisk, and we have to save it in some variable, right? And then we can say in some parameter, right? And then we can say that do what? In A, store what? A, whatever you will receive in A of what key? I want to store this key, right? I can say age of 1, right? Age of 1 key, right? Store in age of 1 key, right? Key's value, and then we can have y equals to 100, and then we can have return a plus y, right? And then we can, okay, so this is how we call when we have too many what key value pair in the argument, and we don't know how many key value pair will be there in the parameters, right? We can also give default value in our parameter, right? For example, a equals to 100, and if for example if we call this function and we don't set the value of a, right? We don't set the value of a, and we call it directly, right? For example, add directly, we are calling it, right? And we are printing it, right? So this time a will be automatically taken as 100, right? Control X, yes, enter. Python C nested.py, right? 200, right? 100 plus 100, 200, right? It has taken the default value of A, right? And it has added to it the value of Y, right? So this is how we can define default value, right? We can create empty function using pass, right? Pass keyword. For example, we have this function. We have this function, right? We have this function. This is an empty function, right? Then empty function, right? And we want to pass the value. We can say pass. I have created an empty function, right? And then we can what call it, right? We can call add, right? Now it will not give us error, right? Else we don't put pass, it will give us error, right? But since in a standard paper, it hasn't given us error, right? So we have created empty function, right? This was about function. This was about empty function. Also in function only, we can pass a list also, for example, if we have some function, right? If we had some function here, for example, add function, and we are accepting some list, right? For example, a, right? Then we can say, let's say we are calling the function and we are giving it a list, right? List of numbers. We can check 23, comma, 45, comma, 67, right? So these are the list of numbers. We have passed inside a function, right? We have passed a list inside a function as an argument, and it will accept it in the parameter, right, column. Then we can say what we want to do with this. We can follow to it for x in this list A, right? A, do what? Print every element, right? I can say print x, right? It will print it, right? Control X, yes, enter. Python's in a standard UI, right? It has printed. Let us understand what is a lambda function, right? So what is a lambda function? Lambda function is an anonymous function, right? So for example, we have something, we define function in def keyword, we can say add, we can have some, what parameters, x comma y, right? And colon, right? And then we can say return what? x plus x plus y, right? Return x plus y, right? This we can define. But lambda function can shortens our functions. Also, it is anonymous, right? For example, let's say we can transform this into a lambda function. For example, let's say I can say lambda x comma y. It will after lambda we will have arguments but with parameters which we are accepting, right? And then can say colon, do what? X plus y, do the functionality, do the function thing, right? Whatever you want to do, right? And I want to store it somewhere. I can say a equals to lambda x comma y. Now it will return the same value, right? It will act as a function, right? Let's say I will remove it, right? And I say, then call this function a of, in place of 10, I want 10. And in place of y, I want 20, right? Okay, I haven't printed in print statement. I haven't given this brackets, right? Python C nested.py 30 has been printed, right? Lambda function acts as a function, as an anonymous function, and it shortens our function, right? Uh, how can we understand the power of it? We can understand the power of it using this. For example, if we define this function inside a function, right? For example, we have some function, add or multiply. Let's say multiply. We have multiply, right? Multiply function. Def, after def, we will give a function name multiply. We are accepting one argument x, right? Then what we can say, what we want to say, we want inside it, we want lambda, right? Lambda, and it will accept what? And let's say y, it will accept y, and it will do what? X into y, right? X into y, right? It will do x into y. Now it will do, and it will return, right? Function value will be returned, right? Return lambda x y, x into y, right? If we try to call this function, right? Let's say I will remove this function. If we try to call this function, right? If we say store in a what? Multiply of, it will accept only one parameter, right? I want to multiply 10, right? Enter. And do what? And then store in z what? A of what we want inside y, right? So first, 10 was stored in X. Now lambda y will require something, right? So we will say here 10 values is stored, and in this function now we want to give it like 20, right? 20 tens are 100, right? So it should print 100, right? Print 100, print what z, right? Control X, yes, enter. Okay, we have to this, use this, right? X, yes, enter. So 200 has been given, right? So this is how it happened. How it happened? First we have given a 10 to this x, right? And then it was accepting another value, lambda y, right? Y it was expecting, right? So we can say a of 20, give y to 20, and then z, give it to z, multiply it and return it and give it to z, and then print this, right? This we can do using lambda function, right? Now how to iterate through each element in tuple and list and put the functionality of the function on each element, right? What we want to do, for example, if we have some what how to iterate through each element in a tuple, for example tuple or list. For example, we have a list, right? Let's say we have some list, right? We will break down the question, what the question want to say, right? For example, we have a list a equals to 10 comma 20 comma 30, right? We have this list, right? Now, what do we want to do? Iterate through each element in tuple or list and put the functionality of the function on each list. Let's say we have some function, for example, multiplication function. We can say def what? Do what? A add, right? For example, let's say we have a add function, right? And it will add to each element, right? Whatever we want to add, right? Let's say we will accept A here, right? A here we want to accept, right? A parameter, right? And then this, right? And then we can say what to do. Return, return a plus 10, right? A plus 10, right? I want to return whatever value we have here, uh, plus to 10, right? Or let's say I want to multiply it. Let's say, for the sake of understanding, let's say I want to multiply it. I can say def multiply of a, then do what? Whatever you have in a, multiply it with 2, right? Now what will happen? This list will be multiplied 2 times, right? Or this tuple will get multiplied 2 times. Let's say, for example, we have z equals to mul of what? Send a, right? Send control x, yes, enter. We have to print it, right? Print it, right? Print z, right? Control x, yes, enter. 10, 20, 30. Again 10, 20, 30. But we don't want to do this. What we want to do? What is our problem statement? 10 should be multiplied with 2. 20 should be multiplied with 2. 30 should be multiplied with 2. Right? How can we do it? We can do it with a simple function called maps. Right? So map, what it does? Let's say, for example, what is map? So basically, map takes two arguments, right? It takes the function and it takes the list, right? On which we want to apply our what, that function, right? And it will apply that function to each to element of each list, right? So for example, we have map function, right? And this map function will accept a multiplication what function, and it will do what? It will apply it to a, right? And we cannot list this down, right? Because this map function gives us an object, means it is an object and it gives us an object. It saves an object and means an object where it contains that what is the function and on which list it has to apply, but it has not applied, right? It will apply, uh, and it has applied internally, but it has not shown us, right? How to show us? We can list it. We can use list function and we can list it, right? And we can say a equals to list this, right? And then we can say print print what a, right? Not a. We can have it in m, right? Somewhere else, right? M. Now list will list out all these elements, right? And then we can say here we don't want this print function, right? And we have did what? We have just called this function, right? Or let's say I don't call the function. I have this function, I have a, right? And I want to map it inside, I want to call map multiply function for each iteration on this list, right? I can say control X, yes, enter. It has given us 20, 40, 60, right? So 10 multiplied by 2, 20 multiplied by 2, 30 multiplied by 2, right? So this is it. This is map function. It is used to iterate over each iteration and give it some functionality, right? Let's say, for example, I want to do it with lambda function. How can I do it with lambda function? So in place of multiplication, we can have a lambda function, right? I can say lambda of what? Lambda of I will accept A, right? I will accept A. Let's say I don't want to accept A. For the sake of clarity, I will accept S, right? I will accept S and do what with it? I will do S multiplied by 2, right? S multiplied by 2, right? And and this is our list on which we want to uh, play, right? Or I can say I can also have A here, right? It doesn't matter. This A, lambda A, is different from that. What? Lambda A is different from what? This list, right? This list A, right? Then we can say control X, yes, enter 20, 40, 60. It has given the same answer, right? So this is about map function. Now we have another function known as filter function. It filters out what? Whatever we want to filter out, right? For example, it gives us the list of elements which are what? Which are true. And the list of elements which are false will not get printed, right? So let's say, for example, we have this list of elements, right? Uh, let's put something here, right? 23, right? Let's I want a list of elements which are even, right? Who all are even, which is divisible by 2, right? So we can say inside save inside Z a list and filter this list, right? Filter this list. Filter will also accept two arguments, right? It will first accept the functionality, right? What we want to do, what we want to filter out, how we want to filter out, right? We can say uh, filter, right? I want to filter lambda, right? Lambda will accept this list, right? Let's say will accept this list and it will do what? A mod a mod 2 double equals to 0, right? It will say a mod 2 double equals to 0. That only I want in this list, right? And I can say comma. I will give the list A, right? A is a list, right? And don't be confused with this A be similar to this A. No, this A is an is accepting an argument. Let's say, for example, I don't want this A. I can put it S also, right? It is accepting an argument, and it is then dividing this argument with 2, and it is saying whether it is 0 or not. If it is 0, then it will be printed here. If it is not, then it will not be printed. Control X, or before that, I want to print it, right? I can say I want to print it, right? I haven't printed it. So print red, right? Print red. Control X, yes. Enter. I can see national pivot 30 and 10 are divisible by that 2, whereas 23 is not divisible by 2, right? So this is how we can use filter function. This is called filter function, right? Now let us understand recursion. What is recursion? Recursion is a function calling itself, right? When a function call itself is called a recursion, right? So how do we define it? We define it using inside the function only, right? We can say def. Using def keyword, we have some, let's say for example, we have a function def and it will print what? First 5 natural number, right? We can say def natural and it is a function and it will print what? Print whatever you will find inside this, and let's say in n we will pass here n, right? We will pass here n, right? So we have passed n to it and we have said print n, but we want to print it till 5 only, so we have to put some condition, right? We can say what? I want to print till 5 only if n, right, n double equals to 5, right? Or you can say n is less than 6, right? Do what? Return it, right? Return, right? Blank, right? Return blank. We want to return nothing, so it will return nothing, right? Or we can say, print n, right? If it is not less than 6, right? We can print it, right? So this is how we can define a function. But now we have to call this function here only. How can we call this function here only? We can call this function here only using recursion, right? What we can say? We can say call it, call the function natural function, call the natural function and give it n plus 1, right? Let's see what happens, right? If we call this function natural and we say in place of n put 1, now 1 will go here, it will check 1 is less than 6, no, it will print 1, right? Then it will what? Add 1 to it, right? Add 1 to it and it will be 2. 2 is less than 6, so this is how it will loop inside this. It will loop inside this function, right? It will move inside this function only, right? Till when 6 is less than 6, no, it will, okay, if 6 is, we have to say if n is greater than 6, right? We have to change the condition. If n is greater than 6, right? So once n greater than or equals to 6, we can say equals to 6, then return it, right? Else 1 is greater than equals to 6, no, then it will print this and it will be natural of call this function, right? Call this function. So we can print it control X, yes, enter. Python recursion.py, right? Python 3, okay, Python 3, right? Python 3 recursion.py, right? 1, 2, 3, 4, 5. It has printed 5 natural number. This is called recursion, right? This is called recursion, right? Now, what do we have in recursion? We have this base condition, right? This is the base condition. If condition, this is the base condition, right? So there was written that I have to print below 6, right? I have to print first 5 natural numbers, right? So we have to below, so there's a condition, right? We have to print below 6, right? So we can say if it is greater than 6, then return blank, nothing will be written. And then uh, if it is less than 6, print it, right? Print it, and we can call the function again, right? This is called recursive call, right? We have called it, we have called a function again, right? And this is what calling, we have called the function from outside, right? A function is called from here. 1 will be stored here, right? 1 is greater than 6. 1 is greater than equals to 6. No, print 1, right? Natural. Again, call this function. 1 plus 1 will be added and it will be 2. Right? Then if 2 is greater than equals to 6, no, then return, will not return, then print 2, right? And then again call this function. How it is happening, let us understand it, right? Let us understand, right? Let's say, what do we have? So whenever we call a function, right? Whenever we call a function, right? What have we done? We have called natural one, right? So when we don't call a function, let's say when we define a function, let me define it here only, right? I can say def of what? Def of, I have said natural, right? Natural. I have defined it, right? And I have said it will take an argument, right? An argument. Then what I have done? I have put the base condition. If n is greater than equals to 6, do what? Return, right? Return it. We don't want dot, right? No dot is required, right? Right. So this was it, right? We will return it, right? If n is greater than equals to 6, we will return it, right? Then if it is not, then print what? Print what? Print n, right? Whatever we have value in n, right? And then what we can do? We can we can what? We can call this function. We can again call this function, right? This is called recursive call, right? Natural of what? N plus 1. Recursive call, right? And what have we done? What have we done? Then we have, let me write it with my keypad on the right. It is very long, right? So what have we done? We have said def of, let me write it here, right? We have said def of what? Def of, I wanted a small, right? Def of natural number, define natural number, right? Natural function, right? Define natural function. Inside this function, it will accept n, right? I've said it, right? Then what I have said? I have said inside this, if n is greater than equals to what? 6. Do what? Return, right? Return, return nothing, right? Return nothing. If it is not, if it is not equals to, not greater than equals to 6, right? Then do what? Then print n, right? Print n, and then call this function. Then call natural, right? Natural, right? Natural of n plus 1, right? Call natural of n plus 1. We want to increment a value by 1, right? 1, 2, we want to print 1, 2, 3, 4, 5, right? Then what do we want to do? We will call this function, right? Outside the function, we can say natural, right? We will call this function, right? Natural. And we have called this function, for example, with 1, right? And then what it will print? What will be the output? 1, 2, 3, 4, and 5. Right. What happened here? Let us understand. Right. So whenever we define a function, right? Whenever we define a function, right? So in this case, we have defined a function, right? Here we have defined a function here, right? So if I hide the output, here we have defined a function, right? Def of natural n. If n is greater than equals to 6, return this, print this natural. So this is the function definition, right? What happens when we define a function? It does not store in stack or heap memory, right? We have this heap memory, we have stack memory, we have heap memory, right? It does not store anywhere, right? It is stored inside a program, right? So we have some program somewhere inside our system, and this program will be of natural function, and it will store all these function definitions, right? It will not store in heap memory, or it will not store in the stack memory, right? But when we call the function, we have called function here, right? 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 Here, natural of 1. We have called this, right? This natural of 1, we have called this. So when a program is called, what will happen? When a program is called, it is stored in the stack memory, right? We have something in our stack, right? And here natural will be stored, right? Natural function will get stored, right? This is what happens when we call a function, right? And we have called it with 1, right? So this 1 value will be stored also. Natural of 1 will be called, right? Then what will happen? This will be called, and it will reach here, and it will say natural of 1. If n is greater than equals to 1, it will check whether 1 is greater than equals to 6. No. Then it will do what? Print n. It will print n. It has printed. We have some output here, right? It has printed 1, right? Then what will happen? Then natural of 2 is called, and it has not exited the function, has not exited the stack memory, right? It is inside the stack memory only. We have added the function here, right? We have said call natural of 2, right? Natural of 2. N plus 1 means 1 plus 1 equals to 2. Natural of 2. Now it has called natural of 2 has called. Now natural of 2 is here. And then if n is greater than equals to 6, 2 is greater than equals to 6. No, it is not. Then it will print 2, right? Output will be printed, right? 2. Still it has not exited our function. Again, there's again a call for the natural function, right? We can say natural of 2 plus 1. 2 plus 1 is what? 3, right? We can say natural of 3 is called, right? And that is stored in the stack memory, right? We have with us stack memory, and it is stored there, right? Now this is called, and it is again called natural of 3. Then if a natural of 3, this means 3 is greater than equals to 6. No, then it will print what? 3. It will output 3, right? It will output 3 here, right? Then again we have what? We have, then again we have what? We have called, after printing it, right? After printing it, we have again called natural of n plus 1. 3 plus 1 is 4, right? So this natural of 4 has been called, right? Natural of 4 has been called, right? Let me erase this, right? Natural of 4 has been called, right? Natural of 4 has been called, right? Now what will happen? Natural of 4 has been called. Now it will go here. If 4 is greater than equals to 6, no, then return, it is not, then do what? Print 4, right? Now output will be 4. right? Now output here, output will be what? Output will be 4, right? It has not emptied the stack yet, right? No function has emptied the stack yet, right? Then what do we have? Then again 4 plus 1 will be 5, right? So it has called natural of 5, right? No function has emptied the stack, they are inside the stack only, right? Natural of 5, right? This is how function works, right? So natural of 5 will be there stored, right? If 5 is greater than equals to 6, no, we can say that it will not return, right? It will print 5, right? We will print 5, right? Output will be 5 here, right? And again it will call this function, and again natural of 6 has been called, right? Let me use this, right? Natural of 6 has been called, right? Natural of 6 has been called inside a stack memory only. Natural of 6 has been called, right? This function has been called. Now it will check what if 6 is greater than equals to 6. Yes, it is equals to 6. Return. Exit out of this function. Right. Exit out of this function and it will go here. Right. It will go to which was earlier function, which was in the stack. Right. So it is not greater than 6. It will exit out of it. Right. It will go outside. Right. And now here it will not be here, right? It will go outside, it will come back, right? It will go out of the stack, and here our pointer will be pointing to natural of 5. Now it will also, it has done its work, right? It has called its function, and now it will return now, right? So it has called its work, right? It has done its work. Now again it will return to the previous function, right? It will return to the previous function. Now it will say my job is done, I am exiting out of the stack memory, right? So now I can pass the button to you, right? So it has said I have also done my work, I have called you, that was my last function. So I will also go out of the stack memory. I will also go out of the stack memory because I have done my work. Uh, I have called you, that was my last work, this was my last work, right? So I have exited out. Now natural one will say I will also exit out of the memory, right? Stack memory, and this again will exit out of the stack memory, and then we will get the output as 1 2 3 4 5, right? So this is what happens in what function, right? This is what happens. This is the working of a function, right? And this is what happens in recursive function, right? Now here in recursive function we have what? We had base base condition, and we have recursive function, right? This is recursive function, right? Recursive condition or recursive function, right? So how to visualize this, we can do what? We can create a tree, right? We can create a tree, right? Let's say for example what happened first, right? So first it called natural one, right? Then what happened? Then natural one called inside stack memory called natural 2, right? Natural 2, it printed some of its value, right? What happened? Natural 1 is called, this has been called. Then here it has checked whether 1 is greater than equals to 6. If it will be, then it will return. If it is not, then it has printed 1, right? So 1 has been printed when this was called. Then after this 1 has been printed, right? 1 has been printed. Let's remove it, right? Let's remove this, right? 1 has been printed, right? This is recursive tree. We are drawing recursive tree, right? We are drawing recursive tree. So now what happened? One has been printed and then natural of n plus 1, right? So what happened? It has again called natural of 2. In the same way, it has called natural of 3, right? Natural of 3. It has called natural of 3, right? In the same way, it has called what? Natural of natural of 4, right? Natural of 4. And in the same way, it has called natural of 5, right? Natural of 5. And in the same way, it has called natural of 6. Natural of 6. What happened? So what happened? This called this, right? Then this function called this. No one has exited the stack memory. This function has called this. This function has called this function. And this function has called what? This function. Once it has reached here, right? It has reached to function 6. What happened? It exited and it called back this, right? Then it exited and it called back this, right? It exited and it called back this, right? It exited and it called back this, right? And then it exited and it called back this, right? And then it exited and it called back this. This is what happens, and it exited and it has saved that value somewhere, if somewhere it has to be saved, right? So this is what happens when you do a recursive call. This is recursive tree, this is stack memory, right? And this is the function, this is the output, right? So this is it. Now we will be finding Fibonacci number using recursion, right? So how to find Fibonacci number using recursion? Let us understand that, right? So we can say what is Fibonacci number. First, let us understand it, right? What is Fibonacci number? So Fibonacci number are those numbers, right, which adds themselves and form another number, right? For example, first Fibonacci number is 0, then another Fibonacci number is 1, then another Fibonacci number is 0 plus 1 is 2, 0 plus 1 is 1, then 0 plus 1 is 1, 1 plus 1 is 2, right? 2 plus 1 is 3, 3 plus 2 is 5, 5 plus 3 is 8. So these are the Fibonacci numbers, and it goes on, goes on, goes on, right? So this is the Fibonacci number, right? So here what happened, right? So means what happened here? 0 plus 1 becomes 1, right? Then 1 plus 1 becomes 2, right? Then 2 plus 3 becomes what? Not this. 1 plus 2 becomes 3, right? Means this number, nth number, is the sum of its previous two numbers, right? So we have found the what recurrence relation between them, right? Recurrence relation between them. We can say, and this is the Fibonacci number, right? This is the Fibonacci number. This is also a Fibonacci number, right? So we can say that Fibonacci number, Fibonacci number of n minus 2 plus Fibonacci number of n minus 1 equals to what? Fibonacci number of n, right? This is how we can find the recurrence relation. Recurrence relation, how we find out is that we have a problem statement. I have to find the Fibonacci number of n natural number, right? Nth position of the number, right? Fibonacci number of nth position number, right? How can I find out? I can find out if I add that is one previous to that number, right? Fibonacci number of n minus 1, right? Plus if I do Fibonacci number of n minus 2, right? This is how we can find out the Fibonacci number of any number. This is the recurrence relation, right? This is the recurrence relation, right? Recurrence relation, right? This is the recurrence relation. We have gap here, right? We have, this is the recurrence relation, right? Now we also have to find base condition, right? There are three things we need to find out of any to solve anything with what with recursion, right? First we have to find out what recurrence relation, right? Recurrence relation, right? Then we have to find out what base condition, right? What is the base condition? And we have to solve it using what? We have to solve it here. We have to solve it using tree, right? By creating recursion tree. By using recursion tree, right? How recursion tree? We have to draw the recursion tree. I just want to say we have to draw the recursion tree, right? Draw the recursion tree, right? Draw the recursion tree. In three steps, we can find out any solution, right? So first we have to find the recurrence relation. We have to find the recurrence relation, that's Fibbo of nth number equals to Fibbo of n minus 1 plus Fibbo of n minus 2, right? Now we have to find the base condition, right? In second condition, we have to find the base condition. Base condition is what? What are Fibonacci number? Fibonacci number is 0, comma 1, comma 1, comma 2, comma 3, comma 5, comma 8, right? So if we have nth number, then zeroth position is 0, first position is 1, and what? Zeroth position is 0, first position is 1, and second position is also 1, right? So we can say if n, our nth number is less than what? 3 or less than equals to 2, right? Less than equals to 2. What to print? What to, or we can say return. What to return? Return what? That number only. Return that number only, right? And, right? No. 0 plus 1 is 1. 1 plus 1 is 2, right? So what we have to say? We have to say if n is less than 2, right? We don't have to put equals to, right? We can say if n is less than 2, right? Then what to do? Then return n, right? 0, position 0, first position is 1, right? Second position we have to return 2 and it is changing, right? From second position we can say if n is less than 2, return n, right? So this is our base condition, right? We have base condition here, right? We have this base condition and we have what? We have recurrence relation, right? We can use these two things, right? Also, we have to draw the Fibonacci tree also, right? Let's us draw it first, right? We can say, so this is Fibonacci number tree, right? How can we draw? So we can say first tree, right? We can say what will happen first. First Fibonacci number 4. Let's say I want to call fifth Fibonacci number, right? Fibonacci number 5th will call, right? And it will call what? Fibonacci number of 4 plus Fibonacci number of 3, right? And this Fibonacci number of 4 will call what? Fibonacci number of third index and Fibonacci number of second index, right? Here also it will call what? Fibonacci number of second index and Fibonacci number of first index, right? Then here what it will call? It will call Fibonacci number of second index and Fibonacci number of first index, right? And then Fibonacci number of second will call what? Fibonacci number of first index, first index and Fibonacci number of zeroth index, right? This is what happens, right? Here also it will call what? So this is what happens, right? Fibonacci number of second number is, this is the tree. This is the tree, right? Now we can draw this, right? We can create this, right? We can set depth of Fibonacci number, let's say Fibbo function, and I will say what? I will say n, and I want to put n, right? N is the nth index number, right? And then we can say base condition if n is less than 2, right? If n is less than 2, do what? Return, return n, right? 0 will return 0 and 1 will return 1, right? 2 will not return anything. 2 will do what? 2 will print fibbo of n minus 1, right? Plus fibbo of n minus 2, right? This is what happens. This is what happens, right? And then we can say we should return this, right? We should return this value. We can say return fibbo of n minus 1 and fibbo of n minus 2, right? Then what we have to do, we can call the function, right? We can say fibbo of this 1, right? Not 1, we can say fibbo of 5, right? Fibbo of 5, and we can print it, right? We can say print fibbo of 5, right? Control X, yes. Enter. Python 3 recursion dot py. We have some simple like unended drive. We haven't put right in like return value is py from if right control X is enter. Python 3 recursion dot py, right? It has given us 5, right? How 5? So our fifth index value is 5, right? Let us see, right? So what do we have? We have 0 index, first index, second index, third index, fourth index, and fifth index is 5, right? So this value has been printed, right? Now what happened here, right? Let us see. Let us create here, right? I have said what def of fibbo of n, right? Define fibbo of n, right? I can say if base condition n is less than 2, right? Do what? Do what? Return and right. Return this index will be right. And else do what? Fibbo of n minus 1 plus fibbo of n minus 2, right? Fibbo of n minus 1 and fibbo of n minus 2, right? Then we can call this function, we can say fibbo of 5, right? This is how what happened, right? Now let us understand what actually happened here, right? First, what happened? We have a stack memory, right? We have a stack memory, right? First, it called fibbo of 5, right? It's called fibbo of 5, right? Fibbo of 5 is called, right? Fibbo of 5 is called, right? Then what happened? It will require what? Fibbo of 4 and fibbo of 3, right? Now let's see what happened. Now let's see what happened, right? So fibbo of 5 is called. Now fibbo of 5 will be the addition of fibbo of 4 and fibbo of 3, right? This was our reconciliation, right? Fibbo of 5 is called. It is sent here. If 5 is less than 2, no, fibbo of 5 minus 1, which is 4. Then this was called, right? Fibbo of 4 was called, right? Fibbo of 4 was called. Fibbo of 4 is called if 4 is less than 2, return n. No, it is not. Fibbo of 4 minus 1. What is 4 minus 1? Fibbo of 3. So fibbo of 4 is called, right? Fibbo of 4 is called. And then fibbo of 3 is called, right? It is inside the stack because its execution has not completed, right? It will require what? fib of 3, right? And fib of 2, right? It will require what? Fib of 3 will require what? Fib of 2 and fib of 1, right? Fib of 2 will require what? Fib of 1, right? And fib of 0, right? Fib of 0. Now let us understand this, right? So it has called fib of 3, right? Now it has called fib of 3, right? Then what happened? 3 is less than 2. No, return, uh, if it is less than, then return fib of 3 minus 1 is 2, right? It has called fib of 2, right? Fib of 2 has been called, and now fib of 2 inside our stack, right? Fib of 2, right? Fib of 2. Then what happened? Fib of 2 is sent here, right? 2 is less than 2. No. Fib of 2 minus 1. Fib of 1 is called, right? Fib of 1 is called, right? Then what happened? Fib of 1 is called, right? Here, fib of 1 is called, right? Then what happened? Then fib of 1 is called 1 is less than 2. Yes, return 1, right? So it has written 1. Now fib of 1 function has been done, right? It has returned 1, right? This is complete. It has returned 1, right? It has returned 1, right? It has returned 1, right? And it has been stored, right? Now what has happened? It has returned 1, right? It has returned 1, right? Fib of 1 has returned 1, right? Then what happened? Then plus fib of n minus 2, right? It has returned 1 and it has completed. Now the value of n is 2, right? Fib of 1 has been executed, right? Here it has returned 1 and it has returned 1 to 2. What? Fib of 2, right? Fib of 2, it has returned 1, right? To fib of 2, it has returned 1. But a function of fib of 2 is not complete, right? I have to do something with it, right? What I have to do? I have to add it with fib of n minus 2, right? So 2 is here, 2 minus 2 is 0, fib of 2, fib of 2, fib of 0, right? It will go to fib of 0, right? Fib of 0. Now fib of 0 is what? Fib of 0 is less than 2, right? So here, fib of 0 is here, right? Fib of is 0, has been executed. 0 is less than 2, right? So return 0. Return what? 0 means return 0, right? Here, 0 will be stored, right? Now it has completed its execution. It will be removed and it will do what? It will add it to this, right? And then Fibo, then what will happen? Then this whole function got executed. It will return, right? We have return value, right? Return value. It will return it to what? It will return it to fib of 2, right? Fib of 2, right? It will return to fib of 2, right? Fib of 2. Fib of 2 now has what value? Fib of 2 has value what? 0 and 1. 1 means 1. Now fib of 2 has value 1, right? Now what will happen? Now fib of 2 will, so it has returned it to fib of 2, right? Now fib of 2 will again go back to fib of 3, right? Fib of 3. It has completed its execution. It has said, I have done my work. I have given you 1, right? Fib of 3, I have given you 1 plus you have to add something to it, right? Fib of 3 said, yes, I want to add something to it. Fib of 3 minus 2 is what? Fib of 3, right? Here we have fib of 3. We have what? 1, right? Then we can say fib of this minus this. So earlier here what is n was? 4, right? 4 minus 2 is 2, right? 4 minus 2 is 2. No, 4 minus 2, not 4 minus 2. We can say 3, right? 3 minus 2 is 1, right? Then it will say, I want fib of 1 value. Now, fib of 1 value, it will execute fib of 1, right? It will execute fib of 1, right? Then fib of 1 will say, I will give you 1 only, right? I will give you one only. 1. 1 plus 1 is 2. It will be returned to fib of 3, right? Fib of 3 will have what? 1 plus 1, right? And fib of 3 will return it back to fib of 4, right? It will be returned to fib of 4. And then what will happen? Fib of 4 will have this value, right? And this fib of 4 is here, and this will execute like this only. And so what will happen? This is our stack memory, right? This is our stack memory, right? Right. This is our stack memory. And what will happen? It will go here, 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 and it will go here, right? And this will value will get printed, right? This is what happens in the equation. This is the visualization. This is a tree, recursive tree, right? This is what happens. We can uh, find the factorial of a number, right? What is the factorial of a number? Let us understand this first, right? We can say factorial of a number, right? Factorial of a number. What is the factorial of a number? For example, we have 4 factorial. What is 4 factorial? 4 into 3 factorial, right? Isn't it? We have 3 factorial. What it is? 3 into 2 into 1, right? This is what? 2 factorial, right? We can define it right like that, right? So we can use this method to find a recursive relation, right? So what is the recursive relation? N factorial means n into n minus 1 factorial, right? So this is our recursive relation. This is our recursive recursive relation, right? This is our recursive relation. Now what? Now what we have to find out? We have to find out what is our base condition, right? Base condition. So let's say we will start from 1. What is 0 factorial? It is 1. What is 1 factorial? It is 1, right? What is 2 factorial? 2 into 1 factorial, it is 2, right? It is 2. So here the value is changing, right? But here 1 1 is there, right? We can say our base condition is what? Our base condition is what? Our base condition is what? We can say if n is this, right? N what is less than equals to 1, what to do? Return 1, right? Return 1. Else what to do? We can say, using our recursive relation, we can say what? Return n into factorial of n, right? This is our what? This is our recursive relation, right? We can use this in the same fashion, right? Understood but how the binary tree works, right? So factorial of 4, for example, is what? Factorial of 4 is 4 into 4 into factorial of 3, 3 factorial, right? 3 factorial is what? 3 factorial is 3 into 2 factorial, right? 2 factorial is what? 2 into 1 factorial, right? 1 factorial is what? 1 only, right? 1 factorial is 1 only, right? 1 factorial is 1 factorial only, or we can say 1 factorial only, right? So this is how factorial works, right? So we haven't gone this far, right? We haven't gone this far. We can say till 1 factorial, I want the value, right? Means 2 factorial means 2 into 1 factorial, right? And if it is a 1 factorial, then return 1, and it is 0 factorial, then return 1 also in that case only, right? So what will happen? Let us see, right? Let us put this, right? def of factorial, right? Factorial, right? So we can, for the nth factorial number, we can say what? Base condition. Base condition is what? Base condition is what? Are, if what? N is less than equals to what? 1, right? Less than equals to 1, right? Do what? Do what? Return 1, right? Return 1, right? Else, do what? Return, right? Return what? Into n into factorial of 1, right? Factorial, not factorial of 1, factorial of n, right? N minus 1, right? N minus 1, right? This is how we can return the value. Then we can call this function, we can say factorial, factorial, factorial of what? N, right? Factorial of, let's say 4, right? Factorial of 4, right? So that's, we have to print it, right? Yes, done. We have to print it, right? We have to print it. Print factorial of 4, right? Print factorial of 4, control X, yes, enter. Python 3, recursion.py 24, right? So this is factorial of 4. What happened here, right? Let us understand it, right? Let us understand it, right? So we have what? We have done something like this. We have defined a function def factorial. Inside it, we have put some value, right? And we have said if base condition, if n is less than equals to 1, return 1, right? Else what to do? Return n into factorial of n, right? Factorial of n. Now let's say we will do factor of 4, right? Now let's see how factorial of 4 works. Factorial of 4, right? Factorial of, not factorial. First we require what? Let me remove this, right? First we require what? 4 into factorial of 3, right? Then we have what? Then we require 3 into factorial of 2, right? Then we require what? Then we require what? Uh, 2 into factorial of 1, and it is 1 only, right? It is 1 only, right? Then we require what? Factorial of 1 into factorial of 0, right? Factorial of 0, 1 into factorial of 0, right? This is what we require, right? Now we have this stack memory, right? Stack memory. First we have called factorial of 4, right? Factorial of 4 will be called. Then we can say factorial of 4 is less than equals to 1. No. Return 4 into what? Factorial of n minus 1 we have put right here. N minus 1, right? Let me remove it. N minus 1, right? We have set this, right? So 4 into this 4 is multiplying here with factorial of 3. Now factorial of 3 has been sent here, right? Here in this function, we require 4 into something, right? And we have said factorial of 3. Till then factorial of 3 is solved, we will not we will not have this value, right? Factorial of 4 value. Then we have factorial of 3. Factorial of 3 is sent here, and it said I am not less than equals to 1, right? I can multiply 3 with here in this 3 into factorial of 2, right? So what happened? It goes from here, it goes from here, it comes here, it goes from here, right? And then it comes here, it goes from here, and then it comes here, right? It comes here, it goes from here. Once we will get this value, we will come here, it will come here, right? It will then come here, and it will then come here, and it will execute the code. This is what, right? Factorial of 2 is called, right? Factorial of 2 is called, then factorial of 1 is called, factorial of 1 is what? 1, right? It has sent back 1, right? Send back 1, right? Send back 1, right? Then 3 into 1, uh, 3, right? It was sent here. It was then sent here. The value has been sent here. Then finally, this was executed and this was removed from the stack, right? So this is what happens in the recursion of factorial, right? This is how we can solve factorial number using recursion, right? So that is about recursion, right? That is about recursion. So that's it for today. We will be understanding OOPS classes in our next video, right? We can say object-oriented programming. We will be starting with object-oriented programming from next video, right? So that is it. Okay.